Students, welcome back. We were doing the qualitative discussion on of the liquid drop model in relation to the semi-empirical mass formula, and what we have done is we have just arrived at a number of assumptions of the liquid drop model of the nucleus. The first one is the drop of liquid is incompressible, and in the same manner the nucleus is incompressible. The nuclear force is identical for all nucleons and nuclear force saturates. So that is these three are the assumptions, and students at the time it was found by using quantum mechanics that the nucleons are not fixed in a nucleus. The positions of the nucleus are not fixed inside the nucleus, just like that of a solid. Actually, you see, in the solid what happens is that we have the fixed, they remain fixed in a position, the molecules are fixed, and so if the molecules are fixed, they will vibrate about the mean position, which you might have had some idea when you studied atomic physics, that in a solid the atoms, they have got vibrational motion, even the molecules, they have got vibrational motion. So when they have this vibrational motion, then what happens, the energy is very big, and this would not be possible for the nucleus if they vibrated about the mean position, being fixed at the position, then the energy would be so big that it could not be contained inside the small dimension of a nucleus. Since the nucleus is stable, it means that the neutrons and protons, they don't have such type of motion, they are not fixed, and they move around freely. Actually, they move around freely inside the nucleus, just like the particles of a liquid. So that's why the similarity, and that perhaps the nucleons inside the nucleus can be considered to be like liquid drop particles came to being, and so that was the actually basis of the liquid drop model. And the idea that molecules in the drop of liquid corresponds to nucleons in the nucleus is confirmed due to the following similarities. Let us see what are the similarities. Let me find some space out here. So that was the assumption part. Now we go to the similarities. Similarities between a liquid drop and the nucleus. So this is to be known, and is also important from examination point of view. This is often asked, what are the similarities between a liquid drop and the nucleus? The first one is nuclear force. It is analogous to surface tension force of a liquid. The surface tension, that is found to be like this, because you see it depends upon the surface area of the nucleus, the volume of the nucleus. And then number 2, I write it here, is nucleons behave like molecules of a liquid. Well, just now we saw that they do not vibrate, but they move about freely, so that is behave like molecules in liquid. Then we have number 3. Number 3 is that we saw in our first unit in the very beginning that density, nuclear density is approximately constant. So constant, it is constant, and it is independent of A. It is independent of constant and independent of A. Independent of A means what? What does A determine? A is the sum of the A is equal to n plus Z. That means the number of protons, the number of plus the number of neutrons, so that this is the sum of all the particles inside the nucleus. That means even though the number of particles increases, the nuclear density is a constant. So this is similar to that even for us, whether it's a small drop or a big drop of liquid, the size of liquid, in the density of a liquid, so density of liquid well, it is independent of drop size. I'll just write it like this, drop size. So write it properly from the study material that I am going to provide you, and then we again saw that the binding energy per nucleon is almost a constant. Do you remember we had a graph like this corresponding to A? When I binding energy per nucleon, B is the binding energy, A is the number of nucleons. So we had a graph like this. So we find that for most of the part it is almost constant. You see this pi part, you see, only for a very small, actually this should be even more steeper, should come like this. Let me draw it properly. So you'll find it in your study materials and my previous videos. So it comes like this and like this. So you find that A is almost a constant from all the molecules. Sorry, all the nucleons, all the elements, or all A. So binding energy constant, which is in case of a nucleus, and okay, it is similar to the constancy of the latent heat of vaporization, And then we have number 5, disintegration of nuclei by emission of particle is analogous to disintegration particle. Emission of particle is what? We know that in a radioactive element, what happens? If I have got a and a Z, then what happens? You must have learned it in your class 12. We have not yet learned it here. What happens? It becomes another element. If it emits a alpha particle, then what happens? It will emit 4 protons, so this becomes Z minus 4 and A minus 2, sorry, Z minus 2 and A minus 4, like this. So this happens like this, this goes on. So by emission of an alpha particle, when a nucleus emits it, this is like this. So I'll write it like this, disintegration of a nuclei of a nuclei, not a nuclei, of nuclei, because nuclei is a plural of the nucleus. nuclei by emission of particles. Emission of particles is analogous to the vaporization of molecules or evaporation of molecules, of liquid. What happens in evaporation? You see, evaporation and vaporization are two different things. Vaporization is when you boil water, it gets transformed to steam. Water gets transformed to steam in a gaseous form, and so it's a somewhat quick process in comparison to evaporation. So this is vaporization. So when you just give fire, but what happens in evaporation? Evaporation is if you that is what happens when you dry clothes, or when you just put some water and keep it on the table. After 1 or 2 days, you'll see that it slowly becomes dry. So this is a slow process, and from the surface the molecules gets evaporated, gets converted to gaseous form. So similar is radioactivity actually. So slowly it is like as if it is being chipped off by small parts of the nucleus, and so slowly the nucleus becomes gets converted to another one. So that is one of the similarities, and there are two more similarities in fact, which I'll just write down. The others are like this. I think we did till 5, so this is number 6, and 6 is like this. Energy of the nucleus. Energy of the nucleus corresponds to internal thermal vibration of molecules. Now, what are thermal vibrations, students? We all know that there is a relation between temperature and the velocity of molecules in gas, but then there is also gas which is moving about in kinetic theory, but then when even in case of vibrating molecules, the temperature there's a thermal connection, because when you raise the temperature they start vibrating more fast. The frequency becomes greater. So this is one of the things. And then the 7th one is formation of compound nucleus. This we'll learn in our next unit when we study nuclear reactions. So just note it down. Formation of compound nucleus by absorbing incident particle. This one you will not understand now. Incident particle you will understand, but I choose to explain it in our next unit. So incident particle is the same as the condensation of a liquid. So these are the similarities between a liquid drop and the nucleus. So I'll stop here for today, and we'll meet very soon.